So, hello everyone. My name's Brian Houstel. I'm one of the leaders of the Carbon Leadership Forum in the San Francisco Bay Area. I'm joined here with some of my other leaders, Vaslav, Massey, Mia, and Ruchi, I think, is here too. Today, we're going to talk about embodied carbon and LCA practices for small and medium architecture firms. Those are the people who tend to be the last ones into new technology due to a litany of issues. And we'd like to cover what those issues are and maybe even try to figure out a path forward so that way all of us can begin to use LCA. So I'll run through very quickly some EC 101 key definitions. I'm sure many of you have already heard all of these, but just in case anyone hasn't, and it's always good to hear how to talk about this because ultimately we need to be able to convince this to a lot of people, especially clients and consultants and contractors. And then Vaslav is going to provide a EC3 demo as well as some more information on LCAs, and then we'll just jump into a nice good discussion. But first, if you don't know, the Carbon Leadership Forum is a nonprofit that works on building the industry in the area of embodied carbon. It's based in the University of Washington. We work on research and resources around the world, and we have a local and we have a global network that's called the Carbon Leadership Forum, and it's located online if you want to learn more. We also have our own chapter website at clf-sfbayarea.org if you want to learn more. We have some events and resources and many initiatives that we're working on pushing forward. So what is embodied carbon? For decades, we've talked about operational carbon, all the energy that's gone into the building when you turn the lights on, when you keep it hot or you keep it cold. But recently we've begun to realize that there's a much bigger part of this equation, one that's arguably more urgent. And that has to do with all the carbon that's released all around the building life cycle. So that's every time something's pulled out of the ground, every time something is made into a product, the transportation to the site, the construction of it, the use of the building, the maintenance of the building, the repair. Those are two pieces I think that are forgotten often, especially with reuse jobs. And then at the back end, the demolition, the transport, the disposal, and hopefully the reuse, recycling, and recovery of that. And so our job is to start calculating what carbon is being used and where it's being released. We can do that by looking at environmental product declarations that are provided by the manufacturer or other standard organizations. And the key here, if you have never looked at one of these, is to look for this GWP number right here. This is what we use to calculate the embodied carbon. Of course, everything else on there is important, but for the sake of this conversation, we'll just be focusing on GWP today. I want to push out there that, even if you have no idea what you're doing, even if you're not doing LCAs at all, every time you reach out to a manufacturer and you're looking for a product, send them an email and ask, or get them on the phone and ask, hey, do you have an environmental product declaration? If they don't, the more times we ask this, the more they hear that they need to start getting these, because this is really important. That's going to be a big push for how we can get product manufacturers to start calculating how much carbon's in their products. So ultimately, we have a tool in place that we can use to calculate embodied carbon for projects, and that's whole building life cycle analysis. There's a wide array of tools, and Vaslav's going to go through all of them. But essentially what they do is we take all of the materials that are going into the building and we calculate the embodied carbon of those using the environmental product declarations. And it comes up with a big number. And we can use that at different stages in our design process to keep ourselves on track and to project how we can do better on future projects. And lastly, as I'm sure you've all probably seen this graph before, I want to point it out again though, because this graph was made in 2018. We're still learning how to calculate carbon. And if there's one thing we should recognize, it's that as we begin to calculate carbon better and better, we begin to realize that we're actually emitting more and more carbon. And so this 11% here, which is a really a huge part of the pie, could be larger, which means that this is even more urgent than it was in 2018. And so with that, I'm going to hand it over to Vaslav to talk about EC3.
Thanks, Brian. And just to correct you a little bit, I will not cover all of the LCA tools, but I'll cover the most relevant ones for us in the US, and also focus on the most affordable ones, I think, for small and mid-sized architecture firms. I understand that costs can be a barrier sometimes, so I'll focus on the cheaper ones. Just to introduce myself, I'm a data and methodology manager at Building Transparency, which is now maintaining the Ec3 tool. And as Brian mentioned, I'll talk a little bit about different tools today from my experience in previous roles, working with architects and engineers, not necessarily under the Building Transparency, with the Building Transparency hat, but the second part of the presentation where I'll be given an Ec3 demo, I'll then wear my Building Transparency hat. So those are the two sections that I wanted to focus on today. Again, since we are focusing on small and mid-sized architecture firms, I wanted to sort of stress three things about this embodied carbon, topic, and that for a whole building LCA, it can actually be quite simple, at least up front. So I'll go over what I mean by that. It's affordable in terms of there are many tools that are free to use for folks, so you don't have to invest a whole lot of money to get started with embodied carbon. But let's start with the and the last one. It's urgent, as Brian mentioned. Obviously, a lot of the embodied carbon or the carbon released into the atmosphere is related to manufacturing of some building materials, and we really need to focus on the whole picture, not just the operating carbon. With that, let me go to the next slide about it's simple. So Brian mentioned a little bit about building lifecycle assessment, and he showed everyone the different lifecycle assessment stages. There was actually a question about what the A1, A2, A3, etc. mean. It's just the different labels for the raw material extraction, transportation, manufacturing, replacement, maintenance, and end-of-life disposal. So each of those stages have their own labels in terms of the letters and numbers. I'll actually cover that right before my EC3 demo. So let me go back into the It's Simple slide. So from a whole building LCA perspective, really what you are doing is taking your material quantities in terms of mass, area, or length of a material and multiplying them by the impact factors. In this case, the carbon factor for the different types of materials. And so as an example, we can have 1 cubic yard of concrete. Excuse my cat. You can have 1 cubic yard of concrete that has an impact factor of 389 kilograms of CO2 equivalent per 1 cubic yard of that concrete. And so if we have, let's say 300 cubic yards of concrete, it's just 300 times that number. So it's fairly simple calculation, but let's talk about where we get some of this information. So the quantities are up to you as a designer. You obviously come up with the design, and you can have different takeoffs, and you decide on the scope that is included in the analysis. And then on the impact factor side, you have the carbon data, which is typically included in different carbon assessment tools that also help you make the takeoffs and the scoping of the analysis streamlined. So I'll talk a little bit about that once I dive into specific tools that are available out there. I'm also including just some basic nomenclature and some basic stuff about global warming potentials and what the kilogram of CO2 equivalents mean on here. We'll share these slides with you, so I'll just skip this part, but it will be available to you after the presentation as well. So let's now jump into the, where do you get the quantities and how does all of this fit into the typical design phases that you as an architect are dealing with. So we start with the BOD, or the concept design, where you don't really have too much information about your building. Probably it's too early for a 3D model or even takeoffs. This is a space where you can either use precedents or just really rough estimates on the amounts of materials that you may have in your building. There are some tools available that allow you to select from predefined assemblies and systems for buildings that are designed to streamline this early design phase life cycle assessment of buildings. Really, in terms of the tools, I'm not sure what everyone here uses, but you can use it can be as simple as using an Excel-based tool or Excel-based calculator, where you simply have the quantities and you extract the carbon data and multiply it yourself. When we move into the schematic design and design development, you probably use some sort of tool like Revit or SketchUp, where you maybe actually now you may be able to export some of the quantities, either mass, areas, or volumes of different elements of the building. And you can use those for extracting your quantity information. But really, if you wanted to, you don't need to make this complicated. You can just stick with your Excel-based spreadsheet and make those quantities more specific to your different designs. Then we get into construction documentation. Again, the 3D model or the quantities can get even more specific. But more importantly, we also start specifying materials. And so this is where you can implement some decisions on what types of materials you actually want to use within your building. And then finally, we have procurement and construction. This is really outside of your scope as a designer, but this is where you would hand off your LCA model to a contractor, and it actually helps to sort of keep track with the contractor and see what worked and what didn't on the project, and sort of learn from it and carry it over to the next project that you work on. You don't need to feel pressure to address all of the embodied carbon questions on your first projects. Just start taking small steps, one step at a time. In terms of the LCA tools that are aimed at the different users, so for a designer, there are a number of tools. Tally here that right now I'm showing Tally, but that's just one example of multiple tools that I'll also touch on in just a bit. They're available out there. But basically, how you can use these tools in the different design phases is at the concept stage. You can really look at is it better to create a new building or retrofit an existing building? What do different shapes and sizes of my building? How do they affect the overall embodied carbon of the building? And you can really just start getting the first understanding of where your embodied carbon impacts are coming from within the building systems. So for example, is it coming from a structure, the envelope, and interiors? Is there a single material that is really overshadowing all the other ones? This is your first look at your project from an embodied carbon perspective. The second phase is comparing different systems. So now we are set on the shape, and we're, for example, building a new building in a certain location. We can now start evaluating different systems for the building. We can compare different structural systems or different envelope systems as a whole. Just general comparisons. No details about picking specific materials within those systems, but just generally. And then finally, in the construction documentation phase, that's where you have your systems in place, and so now you can start looking into different products that are offered by different manufacturers and how they fit into my design now in the construction documentation phase. This is also where we can switch from a design-focused whole building LCA tool into a tool that has a database of EPDs, such as the Ec3 tool, which I'll show you in just a few minutes today. And then finally, if you have the design and you can hand it over to the contractor, again, you can track the rest of the embodied carbon process in procurement and construction. The last thing that I would like to point out here is that I would advise to pick one design-focused Building Lca tool and just stick with that one tool throughout the whole design process. There are some different assumptions that the tools can make that will yield slightly different results. Really, the goal of the design tools is to allow you to compare different designs that you are considering in your own project, considering consistent data. So if you start mixing and matching tools during this process, you don't necessarily get a level playing field in terms of the designs that you look at. And so lastly on this slide, in terms of responsibilities, I think this is fairly straightforward. Again, the architect is really involved in the first three, well, there are really 5 phases of design lumped into 3 images here, but that's where you as an architect have the most leverage in the project. And the reason why we say that it's important that architects start using these analysis tools is because they can educate the owner and developer about some of the decisions that they make on the project. And they can also set the contractor up for success depending on the design of the architect. And so that's it in terms of how Lca tools fit into the design process. Now let me talk about the scope and what typically is included in LCAs. Generally, at minimum here in green, we focus on the structure and enclosure systems. Structure really typically has the largest percentage of the embodied carbon impacts. So if you can actually reuse structure, that is, you are avoiding a whole lot of embodied carbon right there. With enclosures, there are different types of systems that you can compare. And then interior systems are good to have in these analyses, but they can get a little bit more tricky to account for. You have to start accounting for replacements of some of these materials over time, either because of durability issues or because of just aesthetic replacements, let's say on a 10-year rotation cycle. On the top right corner, we have, if you're familiar more with Revit and you deal with some of the Revit categories, these are the types of categories that you can select from in the Tally tool. So again, it includes the same type of structure, enclosure, and interior elements, but it's just showing it to you in a different way. And then finally, if you're more familiar with the division structure, these are the typical divisions that are covered in whole building LCAs. Now, in terms of an overview of the carbon data and tools, we have the whole building LCA tools at the top, which will be, I'll give you some of the sneak peek into the tools that are out there in the next slides. And then I'll jump into the walkthrough of Ec3 and how you could even use that tool in the design process. In terms of the costs, so actually let me back up a little bit. So we have different types of tools. I think the most available tools for someone that is just starting with embodied carbon are different Excel-based calculators. In this case, we have the Athena Eco Calculator and the upcoming Beam tool, which is not publicly released yet, but should be available soon. It's really focused on smaller residential projects. We also have the BIM integrated tools. So if you are using something like Revit or Rhino or SketchUp, you may be able to integrate some of these other tools like Tally or Click Lca, although there are some costs associated with these tools. And then finally, we have some standalone tools such as the Athena Impact Estimator, and Click Lca can also be a standalone tool that you can use if you just want to input your material quantities straight into those tools themselves. I'm showing the costs of these different tools. You can see that a lot of them are free, and especially with the Excel-based tools, it's really helpful for someone that is just starting out with embodied carbon. In terms of the main features, the Excel-based tools typically have predefined assemblies, and so it also streamlines the amount of time that you have to put into actually modeling and selecting materials for your building project. Mostly for the BIM integrated tools, the tools are able to extract the dimensional elements from the 3D model, but then you have to assign each individual material themselves. So that's why here I say that Tally and Click Lca are at its core material databases with the embodied carbon information embedded within them. They also have different assembly builders, and so they really tell you what sort of materials you need to specify within your building assemblies. And so with that, let me just give you a quick sneak peek into some of these tools. Again, this is not an exhaustive list of tools, but tools that I thought might be the most useful for someone that is just starting out with embodied carbon or doesn't have all that amount of time to actually, invest into research into some of the building materials. So let me start with the Excel-based Beam tool from the Builders for Climate Action. This is the tool that I mentioned is not released publicly yet, but should be fairly soon. You have at its core, you have a selection of predefined building materials or building assemblies. You can define the general quantities in terms of, for example, the area of the wall system, and then select which type of material you are using for that system. It gives you a nice summary in terms of the different structural and envelope systems. In general, the amount of material that goes into each of these systems. And then on the right as well, you have the total kilograms of CO2 equivalents. So this is the embodied carbon quantities right here. And then it also gives you an overall number on a per square foot basis for the entire building. Similarly, the Athena Eco Calculator is an Excel-based spreadsheet tool, and it's structured in a similar way. You have different types of systems with predefined assemblies. Again, you select the square footage, for example, for different foundations and footings, for the exterior walls as well, and some of the other selections are similar. Here, for example, in the exterior walls, you can see that it's based on the main structural material within that wall, but it also includes cladding, insulation, weather-resisting barriers, and the interior finishes. And so you don't have to assemble all of these yourself. You can just pick from the predefined assemblies. It's fairly straightforward to use. In terms of the results for this Athena Eco Calculator, you again get summaries by assembly, and you get the GWP, the global warming potential, which is the embodied carbon associated with those assemblies. Since we're talking about Athena, Athena also develops its own standalone tool, which is the Athena Impact Estimator. It's a little more involved to use, but again, it's free to use. So if you actually are looking for a more sophisticated tool where you can define your own assemblies just by picking from a material database, this would be a good tool to test out. This tool is also more updated than the Eco Calculator. Athena stopped updating the Eco Calculator a couple of years ago, but it is still a good tool for someone that is just starting out with embodied carbon. Again, here are just some screenshots of the Athena Impact Estimator and some of the selections that you have to make for defining the different assemblies and the materials within your building. And then we get into some of the BIM integrated tools. So Revit and Tally is one of them. I know we have a couple of folks on the call today who are familiar with using these tools, so hopefully we hear from them about their experience and suggestions for using this tool. But let me just go over some of the basics, how these tools work. So you have a Revit model that has the different dimensional elements of a building in terms of volumes, areas, etc. You can also define the material layers within different elements of the building. And then once that's defined, you can open up the Tally plugin, which is a database of material information and the embodied carbon information related to those materials. you have to do the linking of individual elements to the materials that they align with. And as I mentioned earlier, this is also an assembly builder. So the tool really tells you and gives you options in terms of, for example, stud spacing, gauge options for studs, rebar, amounts of rebar in different concrete elements, etc. And then finally on the right, you again get similar diagrams in terms of the global warming potential and the distributions between CSI divisions, as well as different elements within the building. And then lastly, the last BIM integrated tool that I wanted to point out is Click Lca. Again, this one is not free, and it's I think it's a couple $1,000s to purchase. So this is probably the least favorable for someone who is just starting out. But I did want to point out this this Carbon Designer, which is really focused on the concept stage where you don't really have a whole lot of information about your building yet. You can generally define the dimensions of the entire building and some of the envelope areas and floor areas. And it has predefined assemblies for different regions in Europe and North America that help you come up with embodied carbon very, very early on in the design process. And so with that, I'll wrap up the overview of the different LCA tools that are available. I have a couple of links for resources just on embodied carbon in general on the left that I think are useful for folks to have. And I also have links to the different tools that I just mentioned on the right. So we'll share these slides with everyone so you can access these links after the meeting. With that, let me jump right into the Ec3 intro and demo, and we'll address any questions or actually just have the general discussion with some of the architects on the call after this walkthrough. So before I jump into the walkthrough, let me back up again into the different lifecycle stages and how the Ec3 tool differs from some of the design-focused LCA tools. So again, back to the question about the different letters and numbers that are typically used in LCAs. Here you can see a detailed breakdown of how the letters and numbers correspond with different lifecycle stages. The production stage, construction stage, use, and end-of-life stage. The whole Building Lca tools focused on design that I just covered on the previous slides, in some capacity cover most of these lifecycle stages from production to end of life. There are typically some use cases that are not covered just because we don't have a good way of addressing them, but that is for another talk. Now, before I jump into Ec3, really Ec3 is a database of environmental product declarations, which really focus just on the upfront impacts of manufacturing materials. So this is sort of the distinction between Ec3 and some of the whole Building Lca tools. Just to give you an idea of what that means in terms of accounting for all life cycle embodied carbon, is the product stage is actually usually the largest piece of the pie. So if you're building a new building, the product stage can account for anywhere, around 80 or 90% of the carbon emissions of the building. The use stage replacement can be significant for envelope and interior components. Again, I mentioned this before. This is where you need to take into account the replacement of different materials and systems. For the structural systems, obviously, those are typically in the building for the whole lifetime of the building. And then the end of life stages can be significant depending on the disposal scenario for the various materials. But again, I think it's for another talk. So with that, we'll go into a demo of the Ec3 tool. I'll switch over into my browser. And I think this should be about 10 minutes long, maybe less than that. So let me start at the landing page of Ec3. If you've never used Ec3 before, this is where the tool brings you when you first sign in. Just the general information about what you are looking at here is at the top you have your username, and you can define your user settings up here. You're also linked to your can everyone see my screen, by the way? Just making sure. I think so.
Yes.
Yeah. You are also linked to your organization. So for example, if you're part of an architecture firm and you click on this logo, it will take you to the organization page. And then on the top right, you can select your measurement units. So this really changes the units that you are using for your building projects between SI and USA units. And then in the top right, you also have the settings. The glossary and FAQ are good resources for anyone that's new to the tool. We also have different tools and tooltips around the tools. For example, on the top right here, we have the tour. If you click on it, it will take you around Ec3 and shows you what you can do with the different functionalities of the tool. So I'll leave that there. I just wanted you to know that some of these resources are available throughout the tool. Now, the two main functionalities of the tool are just looking for environmental product declarations for individual materials, and also using the Plan and Compare Buildings tool, which is basically connecting your material quantities for your building projects with those environmental product declarations. So this is the Plan and Compare Buildings is the most relevant one for architects. So let me go into this. If you start in My Buildings tab, this will obviously be empty when you first sign in, but this is where you would see all of your building projects that you have already created. You can also see on my screen that all of these are private. We have different ways of sharing projects across teams. To create a new project, all of this is fairly simple. You would click on the plus building project, and that brings you to a brand new blank slate project where you can start defining some of your project information. At the top, it starts with the general information about your project, the name, the address, the building use type, and the approximate construction start date. A couple things that I would like to point out here is that the approximate construction start date is useful for selecting EPDs, and selecting the ones that have validity dates before this time. So that is one thing. The project address is good to define because you can, if you define this, you can then look for EPDs within a certain distance from your project. So all of our EPDs have locations of their manufacturing plants embedded. All of that information is embedded in the tool. So you could, for example, select a concrete that is within 10 miles of your project. You can also select your own image for the project, and some of this also gets automatically filled out if you are using something like Revit and BIM 360, and you just import the material quantities into the tool. I'll skip the building classification, the reference and comparison, some of these other tabs, I think, for now. Again, you can go into the building planner on your own and sort of explore the tool and explore some of the functionalities. But I do want to focus on the lower part of this. So this is where you start defining your quantities and assigning materials to those quantities. So first, you always want to define the building area, just because at the end you can get the embodied carbon per square foot of your building, and you can compare it across your portfolio of buildings. So that's one thing to define. And then we finally get into defining the quantities and types of products that you're assigning to your building. So this is basically functioning like a Excel-based spreadsheet, except we already have some of the systems predefined for you. You can select from substructure, services, equipment, etc. We also have foundations, superstructure, enclosure, and so on. You can always use your own custom format, but this is just for you to get started quickly. You can start adding elements. Again, this is like adding new rows to an Excel-based spreadsheet. And you can name your element anything you want. For example, we'll just create a random concrete element. And then you can search for the EPD. I'll do that in just a second, but let me just cover some of the other cells that you can see here: the quantity cell, the unit cell, and then this is where you will start seeing the embodied carbon data once you define the materials. You can also add your own notes. For example, if you want to just place some placeholder notes, for your reference for later, or if you want to memorize some equations that you are using in the spreadsheet, you can do that as well. Again, it's just like a spreadsheet tool, so you could have an equation in this quantity tool, for example, 2 times 5, and it will automatically calculate that. So let's say we are defining a concrete element. This would be in cubic yards. So I could say yards cubed, and then I can click on the search button, which will bring me to the search for different environmental product declarations. You have this selection tree based on the type of material that it is. And again, we'll search for concrete, but these are some of the materials that are publicly available right now. We have a number of other ones that we hope to publish soon. We're just working on some of the cleanup of the data in the database. So let's say we have concrete ready mix. Once we select that category, we can click on next. And that will bring us to performance specification filter. So if you're familiar with concrete, you know that you will probably want to select at least the compressive strength. Again, it's as simple as typing in 5,000 PSI concrete. And then you can click the search button. And for concrete, we have a lot of EPDs, so it actually takes a couple of seconds to return all of the EPDs in the database. But once the search is complete, you can scroll down and you can see all of the individual EPDs that fit that performance search criteria. Again, this is like a spreadsheet of all of the EPDs that are out there. You can always select each of them and compare them, or you can look at the details of some of the embodied carbon data. In terms of the overall statistics for your search, here at the top, you see the number of product EPDs that the search actually returned. So there are 8,900 EPDs fitting that 5,000 PSI concrete criteria. And the embodied carbon values range anywhere from 316 to 467 kilograms of CO2 equivalent. Again, this was kind of a broad search. Once you start adding performance criteria, some of these achievable and conservative values will be closer together. I think that's okay. So for the next part on this sheet, I think I'll skip this overview diagram. Again, you can click on the tour of the box plot diagram to learn a little bit more about what it's showing you. But in terms of time today, I will skip this part. I'll tell you how to select individual EPDs for your project. So right now I have this search that I defined for 5,000 PSI concrete. If I did not select an individual EPD and just clicked on use this collection, it will assign just that general value for that material type to my quantity. And so now we can see that, that this field for the collection is showing ready mix strength 5,000 psi, and we have the quantity of 10 cubic yards. Now you can see that we have the embodied carbon value for that line item, 4.67 thousand kilograms of CO2 equivalent. So, so this is the generic way of selecting materials. Again, I think this is the most useful for you as an architect, where you don't necessarily want to select specific design mixes, and you just know very generic information about the type of material that is being used within the building. When we go back into the search and do the search again, just to show you that you can also select specific EPD for your project. So if you click on any of these rows, it will be highlighted in green. It will show here as a selected material. And now if we click change this element, it will actually apply that, that particular EPD value to your entire project. But again, this is more relevant to contractors when they are actually procuring specific material types. So I think that's the I think that covers the general idea of how this tool works. It's really set up to be quite simple. I do want to go over some of the summary charts, but let me switch into a project that is a little more developed. So I have two projects here that I actually prepared for today, the CLF SF Building Design A and CLF SF Building Design B. They're almost identical, so you won't see a whole lot of differences between them. But if you are back inside of the project, and I scroll down to my material quantities, basically the takeoff, you can see that I have many more elements defined, and many of them actually linked with different material searches. And so now if I scroll back up to the top and click on the show summary charts, I can select from different types of charts to view. For anyone that is working on lead projects, this lead bar chart may be a nice one to look at. So what it shows you is the building total, embodied carbon on the left, and it shows you the CLF baseline as well as the materials that you selected for your own building. And then it shows you the results for the different types of material categories, such as concrete, steel, wood, aluminum, insulation, gypsum board, etc. There is another way that you can look at results, and it's the Sankey diagrams. Again, I will not go into too much detail, what this is showing, but we have the individual elements all the way on the left that you selected. So we have rebar, ready mix concrete, gypsum, insulation boards, etc. You get the point. And we also get how those connect into the different types of systems within the building. And then all the way on the right, we have the total embodied carbon for the entire building. And you can see that there is a big difference between the worst case scenario and the best case scenario based on just material selection based on EPDs. Again, we have a Sankey diagram tour, which gives you a little more information about each of the individual elements. In the interest of time, I think I'll wrap this up. The last piece of information that is helpful here is the downloading reports. You can export any of this information into an Excel-based format, and then you can always modify your quantities, etc., outside of the tool as well. So when we save and close everything, okay, the very last piece of functionality that I wanted to show is if you have multiple building designs predefined, like I have here in terms of design A and design B, you can select those multiple buildings, and then this compare buildings button shows up. So what you can do is bring those up next to each other and see how they compare. You can see that in this case, I only have 1% difference in these two buildings. But I can also look at the amounts of embodied carbon that are attributed to the different types of materials within those buildings. So again, this can be helpful when you're comparing different types of designs for the same building project, and you are trying to understand how different general material differences compare across your building designs. And it's 5:48, so I think I'll wrap it up here. I think we'll open it up to questions and also to architects' feedback about some of the use of different design-focused LCA tools and their experiences with them, lessons learned, or anything that they would like to share with folks on the call. So I'll hand it back to Brian.
So thank you, Václav. That was really helpful. We'd love to hear from architects who have, not necessarily with EC3, but who have started using LCAs in their firm. And we would love to hear, not just how you use it, but how you got started using it. Was it you as a principal who started up the conversation? Was it a designer that came to you and brought it up? Was it a client or a contractor? How did that conversation get going, and what were kind of the obstacles that you ran into along the way?
Is there anyone who would like to take the lead? Larry, do you want to go ahead?
Sure, I'll start. So I started thinking about embodied carbon before there were any of these tools. So the first thing we looked at actually was an AIA book that came out in the late 80s, or I guess early 90s, that Bob Berkebile put together with others. That was just on sort of, it was the first place I saw embodied carbon mentioned for materials. And even back then, we kind of knew that concrete was probably one of the worst in terms of impact. So for the first probably 10 years of trying to work with this, we just focused on making better concrete. That's all we did. We thought this is where the biggest impact is, so we're just going to use lower carbon concrete, and we're going to use fly ash just like that. And we didn't know what we were doing at all, because we did things like in our specs, we'd say we want a 30% fly ash in our mix. And what they would give us is the same amount of cement and just add 30% fly ash. So we didn't reduce the cement at all in our concrete mix. We didn't know how to write the spec initially. So we started getting more sophisticated. We worked with people like David Marr and various people to write specs that captured it. But it wasn't until about 2009 we did a project where I wanted to look at the total carbon footprint of all the materials. And we actually didn't use any of these tools because the tally wasn't out yet. We did the ICE database. So we built our own Excel spreadsheet of material quantity takeoffs, and we just added in the numbers from the ICE database for different materials, which I would recommend people looking at that, only because it gives you can look at relative carbon impacts per square foot or per unit, whatever it is, for different materials, and get a sense of where the high embodied carbon materials are. You don't have to, so it's a way of understanding embodied carbon without having to understand a tool yet. And so it's a primer kind of for you. It's not that they're totally accurate. It's not that there's not problems with them, but the ICE database, which is available through Circular Ecology out of England. So first of all, it's an English database, so it's not totally relevant, but it's not that far off. Since materials have become a global market now, it's not that different. So we used the ICE database for years, actually, on our projects, just putting in our own material quantity takeoffs, and we'd got the quantity takeoffs from our cost estimator. Our cost estimator would give us a cost estimate and the material quantities for each of those cost items on our list. So it's another great way to get material takeoffs is through, if you have a good quality detailed cost estimator, they'll actually give you quantity takeoffs sometimes. So that's kind of a story of how, and we're now using Tally in our firm. We've used a little bit of Athena over the years. I've looked at Click and haven't used it yet. And now that we're doing almost all our projects in Revit, Tally's a great way to go. The only problem with Tally, I would say, is that I don't think it's a great tool for really early design decisions. It's when you have your building assemblies all defined and your material takeoffs come out of the Revit model, that it's really great. But if you're trying to decide in the very beginning, am I building a concrete frame building or a steel building, and it's going to be harder to pull that out of Tally, in my experience. So I think it's also, I would say, good to understand sort of basic rules of thumb about where the embodied carbon is in a building. So as Václav mentioned, it's a lot of it's in the foundation and the structure, especially if it's steel and concrete. Even for a wood frame building, a lot of it's in the slab, if it's slab on grade. Maybe half the carbon in a wood frame house is in your foundation sometimes. So it's good to understand those, because in the early stages when you're getting into this, focus on the materials with the biggest impact and just try and reduce those. Don't get hung up on trying to pick the best sheetrock to get you 20% better performance out of your gypboard. Focus on the concrete. And the other thing that's great is if you're in the Bay Area, this is a Bay Area focus group, right? The Bay Area is probably the best place in the country to be for low carbon concrete mixes. Central Concrete is unbelievable. They've listed thousands of mixes, and you can get the exact specifications and then just go for the lowest carbon mix you can find that fits those specifications. So it's great. I should probably stop talking for a while, let someone else talk. But that's sort of, I do think that it's good to educate yourself about embodied carbon, where the big impacts are, how the IC database is great to look at where the impacts are for all materials. You'll find out that plastics and foams on a weight basis are as high as steel sometimes in terms of the embodied carbon footprint. So you learn things by looking through that database. But I think Tally is an amazing tool. I think the Ec3 tool is an amazing tool when you get to that phase where you're actually selecting products or you're helping select products. But it helps when you're getting started to kind of focus on simple things you can do to reduce carbon pretty quickly in your project, and don't get hung up in all the details.
Thanks, Larry. I wanna jump on and say that we put out that entry survey and we got a lot of feedback, and some of the issues that came up were time being one of the biggest issues. How did you convince your firm or your clients that you're going to start spending time on embodied carbon, especially when you brought Tally into the mix?
Well, first of all, we don't do all our projects in Tally yet. We've just done some. So we sort of pick the ones we want to look at. We're actually going back and doing retroactively. We're doing some projects that we already have to sort of see how they do. So we start to build a database within our own firm. I'm not actually a Tally or a Revit operator. I don't do that work in my firm. So I rely on other people to do it. And so I think what I've heard from the people that are doing Tally is that the most important thing is learning enough about it so you know how to build your Revit model so it'll accommodate the Tally takeoffs really easily. If you don't define things right, it can be tricky. In the first few Tally projects I was involved in, we had all kinds of issues with the Revit model, not the Tally model. The things weren't named right, so it was difficult. So learning it is I don't think it adds a lot. I think the more you use it, the easier it gets. If you've already got a good good Revit model, the tally is not a big add-on. But even before you commit to a tool, you can sort of work with your structural engineer and say, okay, we want to reduce the embodied footprint of our concrete mix by 30 or 40%, and there's ways to do it without knowing anything. So, in terms of time, the early embodied carbon stuff I did was all after hours sitting on my couch with a computer. So there's your answer for time. It was just it was just a commitment to doing it. And we have a number of people in our firm that really are interested in it, but it's hard to find the time. It's bigger than the money. $1,000 for a tool is less than, it's not that many hours of time for somebody. So the cost of the tool is less important than the time it takes. If you can find a client that's willing to, you're going to sell them on why it's cool to know this stuff and why it's important to know this, then you maybe will get a few extra bucks to help pay for it for the client. But I would say that for us, it's mostly just overhead. It's not built into a project. We don't have a cost for tally right now in our projects.
Cool.
So I know a lot of the time goes into actually the modeling, especially if you're looking at Revit, right? And you mentioned that modeling the elements correctly is a big piece of having a successful tally analysis, right? So I wonder, if you do something more simpler in like an Excel spreadsheet tool, do you think that sort of streamlines the time? Do architects already have some of the quantities that are necessary for these type of early analyses?
Well, we don't typically get quantity takeoffs for materials or assemblies until we've gotten into sort of design, at least schematic design, where we sort of know we use cost estimators for most of our projects. We don't do residential, really pretty much doing commercial and institutional projects. And we use a cost estimator. And even at an early stage, they'll give you, this much square footage of concrete equals this many cubic yards. Sometimes they'll give it to us in units we have to convert to weight, because it's typically done in terms of mass. That's how the conversion is done for embodied carbon. So, but it's pretty easy to build a simple thing, like if you have this many square feet of stud wall, it's pretty easy to do a conversion to figure out how much wood is in that wall. Once it's not that, which is what I did in the early versions. I just built my own Excel spreadsheets. But again, if you're just focusing on concrete and maybe the superstructure, which is probably where 50% at least of your carbon is, it's not that many elements to model in an Excel spreadsheet. I think that is a good idea to do it. And you can even use the IC database for a rough check on your embodied carbon per unit. It's not that, it is a good way to go. I don't know, since you work with tools way more than I do, Clive, I don't know how you feel, how easy they are as a beginner as a way to get into carbon, or whether you already have to know something about embodied carbon for them to be effective. I don't know what you think of that, but I've always felt that it was good to educate yourself about sort of the general principles about where the carbon is in the building, and then tackle those few elements first.
Mm-hmm. Yeah, definitely. I agree with that. And I think that's where, if you're just starting out, if you look at a single building and just do a couple of rough estimates on 3 different materials, or, the structure and part of your wall assembly, just starting out small, and looking at some of the projects maybe that you already have, you mentioned that as well. Doing sort of retroactive analysis will teach you a lot about the opportunities that you have on future projects.
Yeah, and the other thing I would say is think about materials that the material you pick can actually make a difference. If all the materials in that category are roughly the same, then it doesn't really make any difference to analyze the different options available, because there's not going to be that much range. You'll find pretty early on that a material like aluminum is incredibly high embodied carbon, and you can try and eliminate using it. That would be the first. So high carbon materials, don't use them. If you have to use them as little as possible. You know, there's kind of rules of thumb. The two rules of thumb that I use for embodied carbon is focus on high embodied carbon materials, which are things like foams, aluminum, maybe some of the metals, some plastics, and then focus on high volume materials. So concrete is not a high carbon material, it's a high volume material. That's such heavy embodied carbon footprints because we use so much of it by weight. But on a carbon per kilogram unit, it's not very high at all. There's a lot of much higher materials in your building, but we don't use very much of them. Mm-hmm. So they don't matter as much. So focus on high volume materials, even wood. If you're using a lot of wood and it's not from a sustainably managed forest, it's got a carbon footprint. To mill it and harvest it and transport it, it's not free. So it's, you know, it's good to figure out those materials that are either high volume or really high carbon materials, and then focus in on those.
Right. So, Brian, we have two questions in the chat box. Maybe we could address those. The first one is, has anybody used Cove Tool and how useful was the carbon analysis in there? Is there anyone on the call today that have used that tool? I have not used it myself, so I cannot really speak to that. And if anyone has done that, you know, you can just unmute yourself and share your experience. Doesn't seem like there are a lot of users who have used it.
You're asking specifically about the embodied carbon analysis tools within Cove Tool, right?
I think so, yes.
Yeah. Okay. I've not used that. We use Cove Tool, but we haven't used that particular part of it yet.
Mm-hmm. So the only thing I think I can say about the Cove Tool is that we are actually working with them. So they are trying to use our embodied carbon data that we have in Ec3, which covers the, you know, generally is covered in environmental and product declarations. So really, again, without diving into the details of Cove Tool, I don't know about the modeling using Cove Tool, but if you're just looking at the embodied carbon data, let's say per cubic yard of concrete or per ton of steel, you could always start with Ec3, you know, just do a general search for a steel, let's say steel rebar or a steel section. And you get that embodied carbon data, you can drop it into your own Excel spreadsheet. So I think if you're just starting out, again, that is the easiest way to start.
I had a question for you about Ec3 because I haven't used it very much. Is if you already know your mix design, your strength and things like that, can you just then, is there a way to say I want the lowest carbon mix available for that strength, for those parameters? Will it sort that way for you?
Yeah, well, let me actually just share my screen again. So I'm in the find and compare materials interface again. And just like you said, so if I have a 5,000 PSI concrete, I can define, well, can define some other elements here. Let's filter by state. So let's just look at California. And anything that's available in California, I can click on search, and then it brings up all of the EPDs, right? So we have thousands of EPDs, but you can sort this sheet by the global warming potential of those products. So if you click on the two arrows on the top right, you can sort that spreadsheet. Yeah, now we see all of the low embodied carbon products. Now again, this is, yeah. And then you can also select, so if you click on these check boxes next to the product names, I mean, these will be all, you know, they're relatively similar, but if you click compare and then scroll back to the top, it will actually show you how similar these types of products are.
My guess is if you filled out more of the parameters, like how much steel you need in or what the slump is, if you filled out all of those, that the number of, it would be a fewer numbers you were looking at, because some of them meet some criteria, not others. So if you filled out everything, it would probably give you fewer choices for that really low carbon concrete, right? Probably.
Yep, exactly. So we can try this with, let's say, CO2 cured standard weight. Now we're getting a little more specific.
Water cement ratio, all those kinds of things. Yeah.
Yeah. So now if I click search.
I think another important thing, sorry, Ali here from WebCore, I've been using this tool. I'm working for a general contractor as a project engineer. One thing I've done specifically with concrete, since typically you won't get that from far away from the job site because it's mixing in the truck. So using that distance from site will drastically break down what you would actually be getting. So just
for sure. Good
Yeah,
point.
Good
Concrete.
So yeah, are there other questions, Brian, in the chat box?
Brian, this is Michael from VMWP. I had a follow-up on the Cove tool. We've started using the Tally tool, but as was noted, it doesn't work too well early on until you have your assemblies vertical and horizontal and foundations modeled. And so we're looking at something that might have that we can use earlier on, and we've started looking into Cove tool, but it doesn't feel like it would have a lot of value that early on. So that prompted my question.
Right.
So EC3 is a good option then, yeah.
Yeah, I think EC3 would be a good start for that. Yeah. Again, just if you input rough quantities, you can connect that with the embodied carbon data. And I just, while we were talking about that Cove tool, I wanted to point out what Allison was mentioning about specifying the max distance from project site, especially for concrete. This makes a lot of sense. You're not going to be importing your concrete hundreds of miles away. So even if we just do that, 5,000 psi. Standard weight concrete, 10 miles. Now I selected this max distance from project site. Now if I do a search, before we had about 5,000 EPDs that it returned. Let's see what we get now. Now we're down to 1,000. Again, this is because the Bay Area, like Larry mentioned, the Bay Area has a large number of EPDs, especially from Central Concrete and some of the other manufacturers in the area that are already invested in this, providing the embodied carbon data. So that's why you see such a large number of EPDs.
So if you're picking something like steel, which is available all over, and you want to pick a really low carbon steel, maybe from Washington, does this calculate the embodied carbon taking into account how far it is from your site? Is that part of the calculation, or is it just the manufacturer of the material?
That's a great question. Right now, it's just the manufacturing impacts. The transportation typically is not that big of a piece of the pie, and we are actually working on adding that stage. The transportation between the plant to the project site. So it will be available at some point. It's just not implemented yet.
Right.
But yeah. Now, just to show you a similar search for reinforcing steel, and this is just general search. We only have 65 EPDs, so you can see the stark difference between concrete and steel manufacturers.
And the other thing about EC3 tool that can be a drawback for small green designers is it just doesn't have a lot of the materials that they're working with. In other words, the alternative materials or the carbon storing materials or all those things that people are starting to work with, it's not in the tool yet. It's not, so you have to go to other sources to get those kinds of numbers for things like straw bale or FSC certified. Well, I guess wood's in here, right? Is wood FSC certified wood is in here, or I don't know how the wood.
Yeah, wood. yeah, what is in here? Let me back out. So there are not too many EPDs for wood products.
Right.
But yeah, we have some basic types of wood in here. So for example, you could do dimensional lumber or plywood, etc.
Well, you probably know this, but I heard recently that several stakeholders are embarking on a new wood EPD, I think, to try to capture more of what we now know to be important about FSC wood and carbon. And Larry, yes, some of us are slowly working on biogenic.
No, I know. It's going to be great.
So they actually end up with the databases. Sort of a slow process.
Yeah. Well, it's tricky, but that's really needed to have that in there. So that, because right now you're just picking between all these standard materials, and you know you can pick the best. You're picking the best of the worst of the worst materials.
But I think, but Chris
Right.
theme does include that.
Right.
Yeah. So that's focused on, you know, the smaller scale.
Right. Yeah.
Yeah, that's right. And that beam calculator also accounts for some of the carbon storing materials, as you mentioned, Larry, which is great. You know, now we get into actually looking at carbon storing buildings and potentially calculating those numbers as well.
And of course, my focus has been on reusing buildings. So I can almost, for most of those reuse strategies, take out a lot of the high carbon materials because it's in the foundation of the structure, which is typically reused in a building. And you're mostly working on finished materials, which are, so the whole footprint of the remodel, the renovation goes way down because you're not replacing the foundation typically. So that's another way to think about embodied carbon is that if you have a building that your client wants to tear down and replace with a new building, start there. Start saying, wait a minute, you've got a huge amount of carbon invested in this building. You're going to tear it down and put another huge amount of carbon in a new building. Maybe the first thing to do is to try and reuse the building. And so so we're working on a calculator that compares total carbon. So it looks at the operational carbon before and after a reuse versus replacing with a new building, and it gives you a quick early design stage saying, is it better to replace this building with a new net zero building or renovate it to an 80% better than it is now building? And it gives you the trade-offs. So because embodied carbon, you mentioned, maybe Brian mentioned that it's sort of the most important thing. But the caveat with that is it's the most important thing if you're building a new building. If you're not building a new building, the most important thing is operational carbon because you're trying to upgrade what you've got. So if you're building new, embodied carbon, you know, is the most important thing over the next 10, 20 years we've got. But if you're renovating, the most important strategy may be to how efficient can you make that existing building. You really have to always think about total carbon, not just one or the other.
Yeah. Great. Do we have any other architects here who want to talk about their experience using LCA, or rather any architects here who disagree and think that LCAs are still not viable options? That they don't understand how we can possibly bring them into our firms.
Do you think that they are not a viable option, Brian?
No, I mean, I think they are a viable option, but I have pushed back at my own firm trying to push these initiatives. And I've gotten through rule of thumbs. That's been the easiest one to convince. You know, saying low carbon concrete wasn't hard, and FFC wood wasn't hard. Convincing not to use steel here and there, and saying that sometimes we got to use a larger piece of wood instead of a smaller piece of steel can be a hard conversation. But convincing that we need to use LCAs has not been able to, I have not been able to convince that at our firm. And it's in part because of the time, but it's also, and I'd love to hear if anyone else is in this scenario, we only use CAD. So we don't have any 3D modeling at our firm, and doing the takeoffs is certainly possible, but it's not as straightforward as if we had even just a Rhino model.
One thing, do you use cost estimators for material takeoffs, or how do you do material takeoffs? Do you do them with the contractor takes them off himself?
Contractor does it, yeah.
Yeah.
And we don't, another thing is we don't bring contractors in very early, and we don't bring a lot of consultants in early, which has been something I've been trying to push a lot too, because I've been finding, the sooner you get consultants in and contractors in on board, it's a lot easier to start this conversation. Well,
this might surprise you to know we've been doing this for 30 years, and we don't use very many LCA tools. We do a lot with rules of thumb, and that's really a great place to start. Just educate yourself on what you can do with the 3 or 4 materials or decisions. I mean, we made a decision years ago that almost all our buildings are wood frame buildings, because it's the scale we work at, it's the material we like to work with, so we're not sort of struggling between steel versus concrete. We always have a foundation, so we always have concrete in our buildings, and we often have some steel. But I just think that just trying to build with materials that intuitively are lower carbon, like as much wood as you can use instead and fewer steel and concrete, it makes a lot of sense. And it's not a hard sell. You can sort of sell it on other reasons, aesthetic or cost sometimes, or so there's lots of ways to get at this. Yeah.
Eddie, you have your hand up?
Yes, good evening, everyone. I would like to touch on the conversation Brian just brought up. I didn't want to talk actually, but when you said we are still using CAD, that brought me to this conversation. I'm an architect, a registered architect. I have a small firm working for myself, and at the same time, I'm a faculty at the college, working on a research to see how we can facilitate all this LCA dilemma to the architect's offices. And I start from the bottom up. I mean, why do we do even LCA? Why should we even do that? And it took me to the question of the sustainability and all that this question of LCA was the baby of the sustainability when I started in 2016 to go after all these questions. In a very small survey that I did, most of the architectural firms, about 65% of the job advertisements in 3 provinces in Canada, because I am in Canada, looking into hiring the people that they know Revit means the tool for BIM. And it's interestingly enough, since I'm teaching both construction management and building information modeling in the college, the way we teach the students is to help architects to run the business. We have to remember architectural firms are the businesses, and they have to survive. They have to have enough money in the end of the day to pay all the bills and staff and all that, and then collect some if it's left over for their retirement. And all of these is, so, I mean, Larry understands what I'm talking about. People thinking we are making so much money, but that's basically not that the case. But anyways, moving from CAD to BIM is a really big transition from lots of firms, specifically small firms. If I'm taking not very many square foot of the work every year, there is not really much into it to get ready for my company, and I would like to stick to my AutoCAD LT and provide my contract document, and then the contractor is going to build it. To the survey that I ran, most interestingly enough, is not very many architects doing material takeoff. Although they have Revit, using Revit, but they don't use the tool with the full capacity. That's so hilarious. And this is the first thing we teach to the construction management students, because they know to have the material takeoff for the first time when they want to run the projects in the construction site. And these are the things that comes in the background of LCA and all these CLF and all that. I mean, I'm a diehard of CLF. I'm a chair for the CLF Alberta, by the way. Václav knows me from back then. But the thing is, we have to bring a viable solution for the small offices to be able to relate to all these scientific, beautiful, sustainable world that we are trying to imagine. Bring them back to a business. If they don't see it as a viable solution, if they can't see the business sense of this, it's so hard to sell. And how we can do it, well, I'm trying to publishing a paper to synopsis of all these, what I'm talking about, and lots of questionnaires and interviews I've done to tell everyone, you need to have a material takeoff in a really standard way. In the start, if you can create a benchmark and a lot of databases coming from the community, and we can create that database maybe 5 years down the road, that would be awesome. And I'm really looking forward to have that. But they have to understand how I can minimize the cost and do LCA. I'll tell you how. By making a proper model. I've seen so many architectural offices are still using Revit as a CAD tool, which is a really, really sad, because they don't build the model. They're just using those lines to making a nice PDF and give it to the contractor, and that's it. The models we are trying to make has to be accurate. The materials we assign to all those elements and components has to be accurate. And then when we do the material takeoff, then you can connect it to Tally, or you can connect it to Athena, and then get those numbers out of that. I mean, we have to see the whole picture. For the architectural practices, they have so much in their plate. If you tell them LCA and it's you know, all these difficulties by putting these EPDs, and you've got to ask it EPDs from the companies and whatnot, they will say, you know what, I will leave it for 5-10 more years, then it will come so easy and then we'll employ that. But for now, this is our job. We are working in the research and we want to help them to do this. It basically needs lots of work and to get lots of numbers from the offices, what's going on in the current market, how many offices using CAD, how many offices using Revit, how many people they are capable to use Revit in a full extent, and then they can get the material takeoff to work with it and then start to manipulating the model. This is just to give you an insight of the Revit still is new, and adding LCA on top of that might be even more heavier load for the small practices to pick up. Thanks for the time.
Thank you.
I just wanted to say maybe one more thing, Brian, about doing like detailed takeoffs. You know, that's why I was thinking that some of these Excel-based calculators, like the Athena Eco Calculator, may be better for someone that is also still in CAD. You can have a rough estimate on the wall area or the floor area, and some of these assemblies are already predefined for you.
I 100% agree with you. 100% agree with you.
If you are doing a first-time analysis of this, and you're just trying to learn about where all the impacts are coming from, that's why I think some of these very, very simple tools with predefined assemblies are very useful to smaller architecture firms that are maybe not in the 3D BIM modeling world yet.
Hi everyone, my name is Mona and I'm with YA Studio. I'm actually a recent graduate. Wanted to speaker that I think one of the biggest difficulty is you're trained Revit even in school, but when you go into the workforce, Revit is used very differently. And it's very, very hard to be trained in the way the workforce is. And I think it takes a lot of firm ownership and commitment to train new staff to get them up to speed and be able to do the things that we should be able to do. But I think what a program for for the carbon leadership is to actually provide courses that have actual models that we can use and do an example project together in more like an educational setting. Because I think one of the biggest barrier is that not only the firms are spending the money in training us, they don't have the money to train in depthly. You know, they can only do so much. And I feel like a lot of young designers are very excited about sustainability. At my firm alone, I know 4 or 5 people who are doing their lead, who are doing their well, who are very excited, but it's very hard to find courses to train for something like this that is at an affordable level and actually really high functioning and able to let us contribute back to our firms. So on your leadership side, if there ever is, I know many people like myself that would probably really enjoy learning about it in a more in-depth way. We currently have a project that we can test it out at, but if we don't have access to the tools to test it out or a trial phase or some guidance, it's like flying blind and it's really hard. Thank you.
That's great.
Thanks, Mona. That's great to hear. I was actually going to ask right now if that is something people would be interested in. We had been talking over the last couple of weeks about doing classes for EC3 or possibly even other software. So it's great to hear. And maybe we'll talk about it and see what we can provide, but hopefully that can be in the future.
And just to add to that, and I think Larry knows this too, but even just talking with UC Berkeley, both faculty and students have said it's ridiculous and embarrassing that we don't have embodied carbon curriculum. And I think they probably need the same support that you just described that firms need. I think design programs are scrambling to catch up, and I think we could potentially really help with that. I've gotten that feedback from so many different directions.
And if you don't mind, I could add one more small thing about when you're studying AutoCAD in school, no one's teaching you about XREFing anything. So even when I go to an AutoCAD heavy firm, I had to be trained very robustly to understanding how to XREF and do all these things. So I think there's definitely a gap between education and real world. And I know that it takes the students' initiative to train ourselves, but any support that we could be given, I know of many people who would really greatly appreciate it.
Thanks again. All right, it's 6:30. This has been really great. Thank you all for coming and having this conversation with us. This certainly will not be the last conversation on this topic. We're going to try to push out more resources, and we'll look at doing classes to see if we can really help bring LCAs to small and medium firms. Thank you.
Great.
Thank you very much.
Thanks,
All right, everyone. Have a great
Thanks,
weekend.
everybody.
Can't wait to see the record. Thank you.
Thank you.